Welcome to This Explainer. Today, we're diving deep, and I mean really deep, into the absolute core mechanisms of human biology. We are totally moving past this outdated, kind of boring notion that sleep is just some passive state of rest. Instead, we're going to decode the precise molecular, cellular, and neurological frameworks to reveal sleep for what it truly is. It's literally the non-pharmacological master switch of your entire endocrine system.
So let's kick things off with a pretty wild, provocative question. Why does missing just a single night of sleep mimic the exact metabolic markers of pre-diabetes? Well, to answer that, we really have to look at sleep through the rigorous lens of cellular biology. When you stay awake for 24 hours, you aren't just feeling tired, right? You are fundamentally altering your systemic biology. Within a matter of hours, your resting energy use completely plummets, your morning stress hormones shift, and your body's ability to handle glucose drops dramatically. But to understand the sheer scale of this metabolic chaos, we first have to understand the biological metronome that's orchestrating it all.
Section 1. The endocrine circadian axis. Okay, so our journey begins at the suprachiasmatic nucleus, or the SCN. This is a tiny, incredibly dense cluster of neurons right in your hypothalamus, and it's basically your brain's master timekeeper. It actively translates the environmental light around you into systemic endocrine signals, coordinating the precise, rhythmic release of over 50 different hormones, day and night. It's essentially the conductor of your entire biological symphony.
Now, getting down to the absolute most granular, microscopic level, inside every single cell in your body, there's an actual molecular clock ticking away. It works as an auto-regulatory feedback loop. Basically, your clock and BMAL1 genes activate to synthesize PER and CYR proteins. And as those proteins build up, they physically translocate right back into the nucleus to inhibit their own creation, which effectively resets the cycle roughly every 24 hours. This incredibly elegant clockwork dictates your entire physiology.
Section 2. Metabolic chaos and insulin. The clinical data we have on this is absolutely staggering. Landmark clinical trials, like Broussard's 2015 study, show that restricting your sleep to just 4.5 hours a night for a few days plummets peripheral insulin sensitivity by an astonishing 23%. So your body's ability to clear glucose from the bloodstream becomes severely compromised. And this happens completely independently of what you eat or how much you exercise. You see, sleep loss doesn't just magically cause weight gain out of nowhere. It fundamentally alters your sympathovagal balance. This neurological shift directly impairs your intracellular insulin pathways by reducing what's called ACT phosphorylation. Without that crucial step, GLUT4 transporters literally cannot move to the cell surface to absorb glucose. The end result? Total biological gridlock. Glucose stays trapped in the bloodstream, triggering systemic insulin resistance and widespread inflammation. And if that wasn't bad enough, this metabolic gridlock cascades right into your appetite centers. Sleep deprivation drastically messes with your satiety hormones. Leptin, which is the hormone that tells your brain, hey, we're full, drops by 18%. At the exact same time, ghrelin, the hormone that's basically screaming at your brain to eat, spikes by 24%. You are biologically hardwired, driven to consume more calories. But get this, it's not just any calories you end up craving. Sleep restriction actually amplifies the daily rhythm of an endocannabinoid called 2-AG. And yes, in case you were wondering, this is the exact same system activated by cannabis. So biologically speaking, missing sleep literally gives you the munchies. It perfectly explains why your desynchronized brain demands a donut at 2 a.m. instead of, say, a bowl of broccoli. Your endocrine system is actively overriding your willpower.
Section 3. The insomnia cortisol paradox.
Now, there is this massive narrative pushed by the wellness industry that high daily cortisol is the root cause of all insomnia. And sure, high-resolution studies do show that insomniacs run at a slightly higher baseline in the evening, hitting about 218 nanomolar of cortisol compared to 190.4 for normal sleepers, along with a slight elevation in ACTH. But the causal relationship here, it is deeply, deeply misunderstood. Actually, treating insomnia is not about just popping supplements to lower daily cortisol. High cortisol is very often just a parallel symptom. It's a genetic vulnerability marker indicating how your HPA axis, that's your hypothalamic pituitary adrenal axis, reacts to challenges. Chronic insomnia is a state of systemic hyperarousal. It's not simply just having a surplus of one stress hormone. Section 4. sex hormones and sleep architecture. We also have to contrast the really distinct complementary roles of estrogen and progesterone. Estrogen interacts with specific receptors in the brainstem nuclei that directly govern our sleep-wake cycles, promoting healthy transitions into rapid eye movement or REM sleep. Progesterone, on the other hand, acts as the relaxing hormone. It's a powerful respiratory stimulant that keeps our airways open and serves as a potent, completely natural sedative. The real magic of progesterone happens through its metabolite, called allopregnanolone. This molecule directly enhances GABA activity in the brain, which happens to be the exact same calming neurotransmitter system targeted by modern sleep meditations, promoting deep, incredibly stable sleep. But during perimenopause, the sudden, volatile drop in progesterone completely deprives the brain's GABA receptors of this crucial neurosedative. And this is exactly why women in this phase experience severe night awakenings and highly excitable brain states. But wait, it isn't just the lack of sedation or those uncomfortable hot flashes that ruin sleep. Emerging science is now showing us that rising levels of follicle-stimulating hormone, or FSH, independently shatter sleep continuity. This happens because those shifting hormones directly disrupt specific K and D neurons in the hypothalamus. And those are the exact neurons that bridge the reproductive system with our core temperature and sleep-wake circuits. Section 5. The somatropic healing state. When things are working right, a healthy sleep architecture is a delicate, beautiful dance between two distinct states. Deep, slow-wave NREM sleep is a highly anabolic state. It triggers a massive surge of growth hormone release, which is absolutely vital for cellular repair, while simultaneously suppressing thyroid-stimulating hormone to conserve energy. Conversely, the dreaming state of REM sleep is essential for modulating vital testosterone secretion rhythms. So what happens when that healing state gets violently interrupted? Look at obstructive sleep apnea, for example. When the airway collapses, the resulting intermittent hypoxia, which is a literal starvation of oxygen, creates this violent biological feedback loop. It shatters your sleep architecture, spikes nocturnal stress hormones, and actively paralyzes the hypothalamic pituitary thyroid axis. This clearly explains the profound bidirectional link we see between sleep apnea and hypothyroidism. Section 6. Restoring nervous system regulation. Okay, remember the SCN we talked about earlier, our master clock? Well, the good news is you can manually reset it. Delivering 10,000 lux of bright light to the retina immediately upon waking acts as a powerful biological anchor. It locks in your circadian phase, signals the end of melatonin production, and rescues your hormonal alignment from the brink of that metabolic chaos. You want to pair this with aggressively dimming your lights in the evening to protect melatonin, and keeping your sleep environment cool, somewhere between 60 and 67 degrees, to help facilitate that natural core body temperature drop required for deep sleep. And for those who are feeling trapped in the hyper-arousal of chronic sleep maintenance failure, cognitive behavioral therapy for insomnia, or CBTI, remains the absolute gold standard. It doesn't rely on brute forcing your cortisol levels down with pills. Instead, it systematically neutralizes the hyper-aroused nervous system and actually breaks the conditioned panic of being awake in bed, doing so completely independently of your baseline hormone levels. Bringing this all together, here is how you can apply your daily optimization protocol. By strictly aligning your behavioral inputs with your evolutionary biology, you absolutely restore your sympathovagal balance. So, eliminate artificial light in the bedroom. Establish strict wake time consistency, yes, even on weekends, to anchor that SCN. Front-load your daily calories through early time restriction eating to align with your peak insulin sensitivity. And make sure any intense exercise concludes at least 2 hours before bed to allow your core body temp to fall. I want to leave you with one final thought for this explainer. If sleep is truly the ultimate, non-pharmacological master switch for our entire endocrine system, what other chronic, modern diseases are simply the downstream symptoms of a desynchronized biological clock? I really challenge you to stop viewing sleep as just a passive necessity and start treating it as the ultimate biological tuning mechanism for a long, incredibly resilient life.